What's up everybody, welcome back. In the last video we implemented getters, getting fields on objects. Now we should implement setters, which should look like this. So let's go into the parser. Let's do like that. And in the assignment parsing, what we have now is passing a pipe operator, and let me see, where is it we hook up on the call? This is interesting. Anyway, let's see what we have. So here an assignment can be not sure why it's called, but whatever. Okay, so a call, a dot, potentially a call and a dot, then an identifier, and then an equal sign, and then an assignment. Or a logical OR. So I'm not sure I get this one yet, but let's see if we can look at the call function. It's like quite far down, I think. Okay. So right now we have an expression which can be a pipe, and then you can assign to that. Maybe that's a little bit weird. That's actually, this lets us do something like, but you know, maybe that's okay because this could return something that we want to assign to, I guess. I'm actually not sure. So here it's going down. So here in the pipe operator, it's always going down the precedence list. And the call is in the unary, so that's quite far down, it seems. Interesting. So I wonder what was this before, like if we didn't have the pipe. Maybe we shouldn't. Let me see here. So where is pipe called? Okay, so it doesn't really matter. I mean, if we have an equals, then right now we say we basically have to have a variable there. So anyway, let's try to move on. So right now we like pass something, and then we say If it's an identifier, or here we call it a variable, it's a variable in the code. But if it's an identifier, then we can assign to that. And then the OR is like before it went down into the OR operator. So actually we have a pipe here. So I think that's fine. Yeah, so we can do something like this. Let's add it first to the syntax tree type. So we have here a set. It needs an ID. It needs an object. It needs a name. And finally a value. And now this is going to lead to some problems. We can start with this one. And let me just like see here. What is it now? Okay, and then there's some other annoying compiler errors that I'm going to fix now. So here we are in the evaluate function, and this one I think is interesting. So it mirrors the getter a little bit. First we should evaluate the object, and then we need to do something like this. Right, we have to match on the class, and then we have to get the value. So let's just do like this. Right, so then we loop over all the fields. If we find a field name that's equal to the provided name, no, so we don't do that. So it's exactly what we don't do. Well, actually, we do want to do this. And then if we find that, then we need to say, like, can I do this? Right, if we don't find it, then we have to push it like so, and then that is just okay. Now, unfortunately, there is something wrong. That's wrong. And Okay, so we needed like parentheses around the variables there. Let's see if this works. And that is interesting. So we can just like put a reference here. Doesn't really matter. Right, and we want to preserve the name. So we just do this. And okay, that's interesting. Can I assign to a tuple like this? Yeah, I can like that. Ah, right, and what should this evaluate to? The setter, it needs to evaluate to a value rather, so we can say it doesn't evaluate to anything. Let's do that for now. And I guess we can do that. Okay, so this is how we would evaluate a set value. Just evaluate the object that we're sitting on. So this looks something like this. Object name equals value. First we evaluate the object. If it's a class, then we can go on evaluate the value. Then we look for the name on the existing fields. If the name is there, we override the current value. If the name is not there, we put it in. If we evaluated the object and it's not a class, then we just give an error. So let's have another look at the book. So anyway, we did this. Let's now, we will still have some compiler errors specifically in the resolver, but let's go to the parser now. Just because I want to think about how this works. So here we're going to say if we passed an expression, so we pass something, and if we then have an equal sign, then the expression can either be a variable or it can be a get expression. So where do we actually return that in here? It's down in call, fair enough. So we can say we have a get with an ID, doesn't matter, object, name, value. Or rather, it just has an, right, get, it just has an object and a name. So let's go back to that one. So that's great, but now we already got the value up here. So now I just want to return a setter with a new ID, same object, same name, and this value. So I think that's that. It's a little bit strange that we have a call to pipe here, but it's just a way of taking care of precedence. It's not actually allowed to have a pipe inside an assign because of this match statement. And yeah, this error message should be updated, but whatever. So anyway, let's go to the resolver and resolve expression. Why are there so many? So let's put it here with the getter, even though, yeah, whatever. So let's put it here with the getter. Now, you know what? I'm gonna put it in like semi-alphabetical order. So set ID object name. Name shouldn't matter. Value. So I think we just resolve the object, and I guess that can fail. And then we resolve the value again with this idea that we always try to go as far down as we can with these resolutions. And that's exactly what he's doing there. He's doing it in the opposite order, but maybe there's a point to that. But anyway, let's now check the compiler. And this guy has to be boxed. And I guess this one also has to be boxed. Or maybe it's already a box. It's already a box. So that should be okay. And right, and then we cannot do that. We have to explicitly name it. And let me not do that. Let me do this. So it's complaining here about the line 599. Actually, anyway, let's try it, but I'm a little bit uncertain if it's gonna work. At all. Well, okay, this instance is like something. Ah, damn, okay. So this object value is a literal value. It's saved somewhere in the environment. Now the problem is that when we what happens when we evaluate it? Like, what happens if we evaluate a variable? Not this one, this one. Yeah, we actually return the cloned value. That is unfortunate. Because it means that we cannot actually modify it. So I could do this, I think. Okay, this is a little bit annoying. So from I and 0 to fields that length, can I do that? And then we say field name fields I0. clone that. Okay, so now we should have something that works. Let's try to run it, and let's say, let's do the bagel class again. We make a bagel. Now I can say something like print b.a. No field name a on this instance. So let's say b.a equals 3. That's great. Now still. And it's because when we get this, we are not actually accessing the value of b that's stored in the environment. We are accessing a clone of it. Now, and that's pretty annoying. And I am afraid that what we need to fix that is some more RCs. Potentially. Some RCs, some reference counting, and some ref cells. Because I really want like a pointer that can really, I want like if it was in C, I would just have a pointer to the object that's stored somewhere in memory, and then I could just go in and mess with it whenever I needed to. And we cannot really do that, so I think we really need this RC ref cell thing again. So, okay, but that's kind of a bigger change, because it's because these literal values, they are not just simple values, right? Inside them, they can have other values. And expressions can now modify the inside of the value. So that's why we end up with a problem. And I think we also have to modify the environment then, because it should return these RC ref cells like we have here. Because the literal value is kind of like living in the environment, but we need other places in the code to modify it. Now, another way, maybe we can do it without changing this type. Maybe we can do it by just changing this type. So let's say this one was an RC ref cell, because then when we clone the value, we are just kind of cloning the pointer, and then there should be no problem. Let's try that. So we need to go somewhere here. Right. So now we have to remember the fields is this. Let's just see what the compiler says. Right, so first it complains about that. Very well. Okay. Now 599 approximately. Or rather it's up here. So now the fields is a ref cell. Maybe we can dereference it and it will be happy. Maybe we just actually just need to borrow it. Borrow and dereference. Great. So I guess we do the same here. Dereference. Right, so now we cannot do this. We have to say interesting, because okay, let me just finish this before I think ahead. So we borrow it. That's just the reference, then we dereference. It looks horrible, but whatever. Then we compare those. And then here we need a mutable reference, but I don't think we can do a mutable reference because we already have these immutable references that are living. So let's say, let's make an index that is, and has to be usize. So let's make it 0. Then if we find a match, then we say index is I and we break. And then down here we will say, actually, say found equals false, found equals true. And then we can say if found, then fields borrow mutably, index 1 equals the value cloned, I guess. Otherwise, fields borrow mutably, push. Let's try that. And this thing again. And now, because this is like an RC ref cell, we don't really need this one. Great. Now, 574. Interesting that this stopped working. But whatever. Okay. Yeah, I guess we clone it anyway because we don't want to take it out of the... And this one we also have to clone. There's a lot of cloning going on. Actually, why am I doing that? I can just do that. Give me another error, but it's fine. Okay, let's try our example again. We make a bagel. We just like check, okay, there's no A. Let's assign to A. Amazing. We got it working, basically. Kind of interesting. It's kind of interesting because the way we treating these literal values is they're immutable values, and we just clone them. So in the first 5 types, it's obviously quite like we just clone them everywhere whenever we like evaluate something or have to return a literal value. We just do a lot of cloning. But the environment also consists of these values. And now we want to modify the things in the value. So in the environment. So for most things, it didn't really matter that the thing we got out was not the thing that was really stored in the environment, because they don't have internal state. Right? A number is a number, a string is a string, true, false, nil. Even the callable is probably okay. I mean, we can imagine changing it. But whatever. What I want to say is that when we finally made it to the instance, then the data on the instance obviously needs to be changed all the time. And we got around that by making the instance, which remember is like an immutable class or immutable struct or whatever, but it contains just a pointer. And in Rust, we need to do this trick to have a pointer to something that we can actually change, unless we want to do like a raw pointer or something, and unsafe blocks or whatever. But yeah, I think that's interesting. That I didn't really think about it, but we ended up having this immutable setup. So in the next video, we will start to look at this. It's also the thing that comes next in the book, methods on classes. And the things we skipped up here in the preceding section was just like, this is what corresponds to our evaluation function, and this is also something we put inside the evaluation function. But next time we go into methods on classes. So let's say that's it for this time, and I will see you in the next one.